and they've got position vectors 4, 0, minus 1, 1, 2, minus 2, 3, 3, minus 6 respectively, show that the angle ABC equals 90 degrees. So that's the question.
So does that mean the angle, does that mean A and C?
I guess it does. But we'll see, yeah. Okay. It may help you to do a drawing, it may not. These are all position vectors, so they are all how you get to A, B and C from the origin. If you just stick down an origin somewhere, a dot, basically we've got one vector that takes us to A. We don't know where it is, it's just a rough drawing. We've got one vector that takes us to B. We've got one vector that takes us to C. And they're talking about the angle A, B, C. So they're talking about that angle in there. Okay? The angle between A, B and C. So that's what they're talking about. Okay. What are the two lines? Now, using just A, B's and C's and zeros, what are the two lines we're interested in that make up the angle?
A to B and B to C.
Yeah, so we're interested in the angle between A, B and BC. So if I go back into vector notation, we're interested in the angle between vector AB and vector BC. Can anybody tell me how I can work out what the vector AB is? I think we looked at something similar to this before. What were you saying, Sam? I'm not sure if you got it quite right. You might have been close.
A minus B. No, B minus A.
Which one are you going for? A to B means we're going from A to 0, or to the origin, and then from there we're going to B. That is backwards A, because A is going from 0 to A. So yeah, that is the same as B minus A. So anytime you do that, it's the end vector, take away the first one. So I'm going to have to shrink down a minute. B minus A, well there's B and there's A, so it'll be 1 minus 4 for the top component, 2 minus 0, and minus 1 minus minus 2. That is B minus A. Is everybody happy how I got that? Okay, I reckon that's minus 3.
No, it's not. It's not minus 2 minus 1. Yeah.
Oh, what have I done wrong? Which line? The middle bit, the top bit, or the bottom bit? Bottom bit. Minus 2, yeah, minus 2, minus 1. Got those wrong way around, thank you. Okay, so minus 2 plus 1, minus 1. So that's the vector AB. So if we could do vector AB, we've already said the next one we need is vector BC. So can anybody tell me how I can jump straight to this equivalent here? C minus B. Yeah, okay. C minus B. I'll shrink it down so we can just see them all. C minus B is 3. 3 minus 6, that's C. B is 1. 2 minus 2 and minus signs. Now we had to show that the angle between here was 90 degrees. What are we actually trying to show then in context of today's important things? If we've got to show the angle's 90 degrees, what have we got to show? What have we got to demonstrate to show perpendicular? We need, yeah, that vector dot this vector equals 0. Okay, so that's one of our vectors. That's the other one. So if I'm doing the scalar product, dotting those together, whatever you want to call it, top numbers, minus 3 times by 2 is minus 6. Middle numbers, 2 times by 1 is 2. Bottom numbers, minus 1 times minus 4 is 4. Add those together, I get 0 as required. So I have shown that the angle I needed was indeed 90 degrees.